Hi, I'm Mrs. B. Welcome second and third grade. Today we're going to talk about science and we're going to focus on matter. And so as we get started, I want us to do a quick review on our 5 senses to make sure that we always are using them when we're exploring the world around us. So quick review, 5 senses. Our sense of taste, which we're not going to use too much today. Our sense of smell, again, we're not going to use that too much today with what we're exploring. Our sense of hearing, we might need that to make sense of some of the things that we are exploring. Definitely we use our sense of touch a lot, and our sense of sight is something we will definitely use. But again, feel free to use wherever you are, all of your senses, all of the time. And so I want us to start to think about some things that I brought for us to explore. So matter is anything that takes up space and has mass. Again, I have matter, you have matter, everything around me here has matter. So let's take a look at some objects I brought for us today and start to explore what they do. I want us also to think back about the lesson on property and purpose. So remember, property is color, if the material is flexible, if it's hard, smooth, rough, and how that property then helps with the purpose of the object. So the first thing I have here is a fan, and today I'm going to take apart some things, and I want you to ask before you take anything apart, make sure it's safe, check in with a grown-up, or if it doesn't belong to you. So some of the examples I have today, I'm not going to take apart because they don't belong to me. And so I have this fan, and I took off the front because I wanted to take a closer look at the blades here. And I probably could have taken a few more steps to take more pieces apart, to see the motor, to see the back, take off where the battery goes, how the switch might work, but I didn't want to do that. I want to keep this as a fan because I'm also going to encourage you to start collecting some things, and I'll talk more about that towards the end of the lesson, because next week we're going to start building some really cool machines. So I took apart this fan to take a closer look at it. I have this flashlight. And if I take off the top piece, as I'm twisting it, the light turns on. And I can take off the top pieces, and I definitely can get a closer look at the light bulb there. It's pretty bright. It has this piece here, which helps with reflecting the light. Shiny piece there. Let me put it back together. And that's the thing about taking things apart. Can't put them back together. We might break them. We don't want to break things. And then it has this plastic clear piece that goes on top, and then this other circular piece that I can screw on. I can also take apart this whole entire top piece, and you can get a closer look at the light. Looks like a tiny candle from where I'm at. Again, I'm going to put the piece back on. I noticed that there was a screw there for me to screw this on. And then I'm going to take apart the back. And inside are 2 batteries. So this object, this flashlight, has a lot of different pieces. And as I'm looking at these different pieces that I can take apart, was there anything that I could use again to make something new? Definitely the batteries. I can put these batteries into some other battery-operated object. Maybe if I wanted to and needed this tiny front piece of glass here. I also found this game that my family and I don't play very often. And I decided to take this apart and open it up. Again, please make sure that whatever you're exploring, you have permission to open it up and take it apart. We don't want to break anything. And so when I took this apart, I noticed all of the button pieces can come off. And this is the front side, and this is what the inside of the back looks like. And I think these pieces, these buttons, were made specifically for this type of game, for this piece right here. I don't see that I could reuse these maybe as easily. I'd have to get creative. And then the next button, it says next on here, is this big button. When I looked inside of it, I see a screen, a circuit board. If I went a little bit further, I could probably take off the back and dig in a little bit more, explore a little bit more about where the batteries start to connect. I see wires. And so if I press the top button, made a sound. That's a timer. The light goes on with the screen. I see some words. The buttons here, this was to push next to give to add score points to the game. You could hear it. This other button also makes a sound. And this here, down here, is to change the screen here. I can change my categories for the game. So this is what the inside of this game looked like. And I saw a lot of different parts, some electrical pieces in here. And then next is this made of blocks. And maybe you have some blocks at home, some Legos. And so this is a model of a digger that you can play with. And it has some interesting pieces. So for example, it has this piece here which I can twist. And then this front part moves up and down. And maybe you can see here that how the pieces move. So they come into a straight line, and then they form an L shape, and then they fold into each other. There's also a piece here where I can also turn, and then my front piece can move. Let's see if I can move it back and forth. It can go up, and it can go down. And when I take a closer look in here, I see a gear inside. And a gear looks like a wheel with some teeth sticking out of it all around. And it is attaching to a screw. So as I turn this, then that screw and gear are making contact so I can move this up and down. There's also a piece at the bottom here that has some openings. And again, I have these wheels in here that look like gears because they have these teeth, these pieces that stick out. And as I move it forward along, that gear piece attaches or hooks onto this piece right here that makes it look like tires. So I can't take this apart. It doesn't belong to me. So I don't have permission to do that. But I can definitely start to see all of the pieces and how they move, their properties, how their shape affects their purpose. I can start to see that. And you can start to see that with a lot of the objects I brought here. And so maybe you have blocks. And what we want to focus on today is how matter can be broken down, disassembled, and put back together or assembled into different parts. So here's an example of a few pieces of blocks that I took. And I have this really cool piece here. Can you see it lights up? And when I take a closer look, I have to push on the side of the block so that the battery will make contact and light up the light inside of the block. That's pretty cool. And if I have another piece right next to it, let me see if I can find an extra piece in here. So I can keep my light on, blinking. I have some other pieces here. I have this piece looks like a window, can open and close it, have an archway. And using toys like this are probably a lot safer and easier for us to build something and take it apart. And so what questions do you have so far? It's important to always ask questions in science about some of the things that we saw today or some of the things that you have when it comes to putting matter together and then taking matter apart. looking at the pieces and the parts. That's a focus of our lesson. So any of the objects I've shown you so far, do you have a what question? What else could I make with these blocks? A what if question? What if the batteries were taken out? Or what if we rearranged the wires if we could? How would this work? How about a when question? When can we reuse pieces and parts of one thing, like this flashlight, the batteries, and when can we reuse them and do something else with them? How? How could I take this apart and create a different type of machine? How can I get those pieces to go up and down in different ways? Why? Why is it important to know how pieces and parts fit together and how we can make new things or different things? Why is that important in science? Why is that important in engineering? Well, it's important as we learn more and more about science that we can take apart matter, put it back together in new and different and exciting ways to help us. And one thing that we can use to help us as we are building new things and putting matter together is the engineering design cycle. Here's one example of one. So let me walk you through some of the steps to help guide you as you start to create new things wherever you are. So we want to start with a problem or a question. Think about what materials do I have? How many pieces will I need? What's the purpose of what I'm building for? And then imagine and plan it out. What will you do first? What will you do next? What are you trying to accomplish? Think about then how you're going to create and build it. So create it and build it, whatever that thing is that you want to make. And then test it out. Ask yourself, did it work? And if it didn't work, what are you going to do next to fix it? Or how can you improve it and make it better? And then maybe you need to go back, ask yourself some questions. Do I need more pieces or parts? Or maybe I need to go back to my planning. Something went wrong, but where did I go wrong? Maybe I need to take a piece apart, put a new piece on, test it again. So you might go through all of these different steps in different orders. But this is a way to help guide us through our thinking. And so I want to leave you with a game, 2 games actually. One game is where you take random things. So for example, I have this leftover from, this actually had plastic wrap on it, but if you have paper towels, you might want to keep the roll. I have a couple of boxes. I have a tin can. So one game is that you take some things that are left over, maybe for recycling, maybe before you throw them away. You start to collect them, and you put them in a bag. And then the game is that you, by yourself, or if you were playing with somebody else, you take a couple of these pieces and give yourself 5 minutes to build something new with these pieces. And if you're playing with somebody else, see who can make the most creative, the most interesting, the most purposeful thing in 5 minutes. Or if you're not able to collect items like this, you can take blocks and count how many blocks you're going to use. So if we're going to use these same blocks again in the game, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 17 blocks here. So I would only be able to use my 17 blocks, and I would give myself 5 minutes, or I would give somebody else 5 minutes. How many new things can you make with these 17 blocks? Or how quickly can you do it? Who can build something the fastest? So today our focus was on matter. Everything that takes up mass and has space, like you and I, like all of the things we saw here. You can explore all the things around you. Ask an adult if you can take something apart safely, or take apart some toys that you have and make it into a game. How many things can you create in 5 minutes? Or who can create something the fastest? And think about their properties and their purposes. One last thing. If you are able to start collecting different items before you throw them away or recycle them, start keeping them, because next week we're going to build some really cool simple machines, and Miss Taurus and Miss Q are going to have a really cool lesson on marble runs. So until next time, I hope you have a great day. Bye.
Good morning, kiddos and families, and welcome to At Home with APS. Happy Thursday. Is it Thursday today? Because last time I was here, I said it was Thursday, and guess what? It was Tuesday. Kind of gets confusing, right? When you're out of routine. But today is Thursday, so happy Thursday, and we're so glad to be here with you. My name is Miss Carnes. I teach math in the school district, and this is my friend, Miss Gaudette. Hello. And she also teaches math in the school district, and we're going to work together today on an activity called off-decade counting. When you do off-decade counting, this means that you are counting by tens, but guess what? You're not starting at 10. You're starting at a different number. So today we are going to count by tens, but we are going to start from this number. Do you know what number this is? It's 7. So we're going to start at 7 and count by tens. Let's take just a moment to think about what our next number is. And then we'll use our hundreds chart to help us, and we'll also build those numbers on frames. Okay, think about, so what is 10 more than 7? Okay, let's start counting. So we have 7, 17, 27, 37, 47, 57, 67, 77, 87, 97. We've already gotten all the way to 97. Let's take just a minute. Oh, thank you, Miss Gaudette. And think about what might be 10 more than 97. Can be kind of tricky when we're trying to cross over the hundreds. Let's just spend a minute. You know, I could use the hundreds chart too to help me think about that. Because, so where do we have, here's our 97. Let's go back to 7. What was after 7? 17, 27. Does that give you any idea of what might be after 97? We know it's going to be higher than 100. Maybe you could use your frames also to help you. So 10 more than 97 is going to be 107. You've got it.
Remember, it's not 107. It is 107. Let's make sure that we're saying the numbers correctly.
Thank you so much for that reminder, Miss Gaudette. So we're at 107, 117, 127, and guess what? We're going to stop right there. Did you notice any patterns that we see on the hundreds chart when we count this way? What do you notice? I notice a pattern of 7s. And I'm wondering if maybe we can mark that on our chart. So, if we look at the numbers we've counted, 7, 17, 27, 37, 47, and we can keep going all the way to 127, we'll notice each one ends in a 7, doesn't it? Why does that happen? Why do the 7s stay the same? We can use our frames to help us understand why. Because we started our count with 7. And the only thing we're adding as we count Our tens. So our 7 is going to stay the same. It's our tens that are going to change as we add more tens. So if we go back to the chart and think about some of our larger numbers, let's take a look at what's happening in the tens place. I notice we go from 7, no tens place, right? Just 7 ones. 17, we have 1 in the tens place. 27, we have 2. 37, we have 3 tens. We can see it. 7, 17, 27, 37, 3 tens, and 1 7 gives us that 37. And so our number of tens is going to keep increasing on our hundreds chart, and we can see that our number of tens has increased as we built on the frames. Let's go ahead and circle those increasing tens. 9. So we've gone all the way from 1 all the way to 9 tens. But when we get to 107, something changes. Our first 2 numbers make a 10. Why is that? Because guess how many tens we have? You've got it. 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 17, 27, 37, 47, 57, 67, 77, 87, 97, 107. 10 tens and 107. All right. So some other things we can do is we could put this on an empty number line and show the jumps that we've made. And a little later in the lesson, you'll be using a number line as well. So let's go back to where we left off, and let's add on. We have 127. Okay, let's continue our count. What would be 10 more than 127? That's right, 137. What if we added 2 jumps of 10 to 137? Where would we land? Think about that. Did you think 157? If you did, you are correct. And you might have thought about making 2 jumps of 10, right? It took us 2 jumps of 10 or 20 to get to 157. Or you might have just thought about making 1 big jump of 20. How many tens would we need, or how many jumps of 10 to get to 187? Let's think about that. 157? How are you figuring it out? Did you count 3 jumps of 10? And get 187? Or did you just think about, to get from 157 to 187, I could make 1 big jump of 30, 3 jumps of 10. All right, what's next after 187? 10 more gives us 197, a nice jump of 10. And here's that tricky one again. So what's going to be 10 more than 197? We have to cross 100 again. Think about it. What was after 97? Does that help you? It was 107. So 10 more than 197 is going to take us to 207. Jump of 10, and we crossed over another 100. And I thank you, kiddos and families, for joining us today for our off-decade counting routine. And I hope that this will help you a little later on in the lesson when you try some activities with my other teacher friends. Thank you so much.
All right, everyone. We are going to start moving into our problem-solving piece. So thank you. We got to think about what are some techniques or strategies we can use to help us solve a problem. Reminder that this problem is up on the website, so if you want to go ahead and find that and download it. And I'm going to go ahead and start us with some strategies to help us out, which is a modified marking of the text. With that, we are doing Carol's numbers. So let's get right into it. We have here, Carol has 3 number cards. She has a 4, a 7, and a 2. Is there any information that we need in that so far? Right? We know we're going to do this. If they're telling us it's the number cards, we know we're going to need the 4, 7, and 2 somehow, some way. So let's read a little further to see if there's more information that helps us out. The first one says, what is the largest 3-digit number Carol can make with her cards? So what should I underline? Remember, we always try to underline what we're working on. What should I underline to help me out? There you go. Thank you. Largest 3-digit number. So I'm going to underline that. I have gotten some sheets of paper to help us with this. So let's think about that. We have a 4, we have a 7, we have a 2. So we're talking about 3 separate digits that I have to put together to make a number. How big is this number going to be? Is it just going to be a 1s in the 1 spot? Is it going to be in the 10 spot? Where is it going to be? How big is it? Right? We're going to have hundreds. So we got to get these 3 digits somehow, I'm going to say modified, but it's not modified. Somehow moved around so that I have the largest number that I can have. So is the 4 the largest digit that we have here? No. What about the 7? Is it the largest? Some of you are saying yes. Okay, well let me check the last one just to double make sure. Is 2 the largest? Nope. So 7 is my largest. So where would I put that on our number? I'm going to move this just a tad. Where would I put that on my number so that it is the largest? Would I put it in my 1 spot? I hear us shouting, no. Okay, I gotcha, I heard you. Would it be in my 10s? Nope, you're right. It would be in my hundreds. So I'm going to put which digit? The 7. So we're going to put the 7 in there. All right, now let's look at the next one, the 4 and 2. Which one would help me out? Can I put the 2 in there or the 4 in there to make the largest number? Thank you very much. Yes, we can put the 4 in there. So that leaves us what number? 2. Thank you for your help. Now, I did forget to mention one thing, that of course you can pause me on the TV, pull it up, do the math before we go over it together if you would like to do that. Reminder, I'm just going through and thinking through it, how I would approach it. So I'm giving you what I call the teacher talk through my own thinking. So if you want to think about it, do it first, and then, of course, you can see how I would approach it. All right. So the next thing says, what is the smallest 3-digit number Carol can make with her cards? Okay. So let's think about what we did last time, how we did the 4, 7, and 2, and we looked for the largest digit. What would we do there? You're right. I heard you talking. I forgot to underline what we're being asked to do, right? So, yep, we are looking for the smallest 3-digit number. But I'm going to take us over to our other one because it kind of helps us out with our thinking as well. So the next part says, explain to Carol how she can make the smallest possible number using her 3 cards. So what do we have to do there? Right? Thank you. We got to explain. Explain this whole, how do you make the smallest number? So I'm going to start us with the explaining, because I personally like to think about how would I approach it, and as I'm approaching it, just write it down so I'm done. So what did we do last time that could help us this time? Yeah, right? We already sort of talked about it. Last time we looked for the largest digit. This time we're going to look for the smallest. So what will we do first? Yep, we're going to find the smallest digit first. So we look at each digit to see which one has the smallest value. All right, and which one would that be? Thank you. So the smallest number, 2, goes where? Thank you very much. It does go in the hundreds. If we're trying to make it the smallest, goes in the hundreds. All right, so I have down here my number, ones, tens, and hundreds. So where would it go again? Thank you. I do appreciate all your help with you guys calling out the answer. All right, next, what do we do next? Reminder, use what we did here to help us out. Yep. Now we're going to try to find the next smallest, right? The next smallest, which is 4, thank you, goes in which place value? The tens. So I'm going to put that 4 there. And then what happens last? Right? The largest number goes in the 1 spot. So the largest number goes in the ones spot. So that was, thank you, it was 7. Okay, so we have Carol's numbers. Has 3 number cards. We've made the largest, we've made the smallest. Now they're asking us to do something a little different. We're given a number line that has a 0 and has a 42 on it. And then we're asked about where would 85 be? Where do you think 85 would be on that number line? Thank you. Some of you were telling me while I was moving that around, tell me where it went. Thank you, I do appreciate that. And I was looking at this, like I could put an 85 way over here, right? No. Is it here, sitting here about? Help me out if it's way out here when 42 is over here? Yeah. So how could we talk about it where 85 would go on this number line? I noticed a few people said, well, 42 is about half of 85, right? So if that's the case, 85 would be where on this number line? Yeah, if you're thinking to this, if 42 is here, right, 85 would probably go about here, so 42 is in the half spot. All right, so and about where would 21 be? Yes, 21 would go ahead. You can see that 21 is about half. So we would put it here. So I am going to leave my last problem with you so that you can look at it, think about it on your own if you haven't had a chance to do that. And then we'll talk about this next time when I see you. So about where would 31 be on my number line? And then tell Carol how you knew where to place it. All right. Well, thank you so much for helping me out with some problem solving today. We're going to move into our read aloud with Miss Obenchain, and you guys are going to so enjoy this book.
Thank you, Miss Gaudet. Okay, today we're going to read a book. My name is Miss Obenchain, and the book that we're going to read is called Night Noises And it was written by Mem Fox, illustrated by Terry Denton, and published by Harcourt Incorporated. While I'm reading this book, I want you to be thinking about what kind of a math problem could we do related to this book? Because at the end, we're going to talk about that. Lily Laceby lived in an old cottage in the hills. Her hair was as wispy as cobwebs in the ceiling. Her bones were as creaky as floorboards at midnight. Her only companion was a fat old dog called Butch Aggie. People who lived nearby said Lily was nearly 90, but they were only guessing. One wild winter evening, as Lily Laceby sat by her fire, snug and warm, and drifted off to sleep, and she began to dream. Butch Aggie dozed at her feet. Outside, clouds raced along the sky, playing hide-and-seek with the moon. Wind and rain rattled at the windows, and trees banged against the roof. Somewhere in the distance, car doors opened and closed softly. Click-clack. Butch Aggie listened. But Lily Laceby kept on dreaming. Feet tiptoed up the garden path. Crunch, crunch. Butch Aggie cocked her head. But Lily Laceby went on dreaming. Voices whispered in the bushes, murmur, mutter, shh. Butch Aggie bristled, but Lily Laceby went on dreaming. Eyes peeped through keyholes, squint, peek, peer. Butch Aggie's throat rumbled, but Lily Laceby went on dreaming. Hands tried to turn doorknobs. Twist, test, rattle. Butch Aggie barred her teeth, but Lily Laceby went on dreaming. Knuckles drummed on door frames. Knick, knack, knock. Butch Aggie leapt up, growling, but Lily Laceby went on dreaming. Fists beat upon doors and voices shouted at windows. Yell, clatter, bang, bang, bang. Butch Aggie barked and barked. Lily Laceby woke up with a start. Who is it? She called. Who is out on a night like this? It's only us. Let us in. Let us in. Creak, crack, went Lily Laceby's knees as she stood to go to the door. Snick, snack, went the bolts on the door. And in came her 2 sons, her 3 daughters, her 14 grandchildren, her 35 great-grandchildren. Surprise! Happy birthday! Put the kettle on. Happy 90th birthday. Her great-grandchild Emily, aged 4.5, and her 47 friends. Surprise! Happy birthday! Are you really 90? Whispered Emily, aged 4.5. Lily Laceby held her hand and smiled. Inside, I'm only 4.5 like you, she whispered back, but don't tell anyone. And that's the end of the story. So what kind of a math problem do you think that we could do today about this book? That's right, we could try to figure out how many people were at Lily Laceby's birthday party. So I'm going to come right over here, and I have a chart that will remind us about who was at the party. And we're going to do mental math today. So that means we're just going to think about it and see if we can look at the numbers and find some numbers that would be easy to put together and kind of keep track as we go along. We can check it afterwards with the problem. So we had 2 sons, 3 daughters, 14 grandchildren, 35 great-grandchildren, 1 great-grandchild, and 47 friends. What numbers could we put together? Well, this 2 and 3 makes a 5, and then you could add that pretty easily to the 14 because 5 and 4 makes 19. And then a 1, we just have a 1, so that could make it 20. So those are 20. If we add 20 to 35, what will we get? We could think about jumping like we were doing earlier. 35, 45, 55. So we'd have 55, and then we just have to add this 47. Well, 55 and 45 would be an easy set of numbers to put together. That makes 100, and altogether we'd have 102 because we have a couple left over. So if we were going to check that, we could write that down. 35 plus 20 equals 55. The 35 is here, and these numbers made the 20. And the 45 came out of this, and then we had 2 left over. Another way we could think about those numbers is we could start with 47, which is the biggest number up here, right? And think about what we could add with that. Well, 47 and this 30 could make 77. And if we add this 10 from here, that would be 87. And then 3, because 7 and 3 makes another 10, would be 90. And then that leaves us with this 4 and 5 and 1, which also makes a 10, because 4 and 5 is 9, and 9 and 1 is 10. And 2 more. And 90 plus 12 would be 102. And we could write that like this. Whoops, I covered those numbers up, didn't I? Starting with the 47, adding that 30 from the 35, adding the 10 from the 14, adding that 3, because that 3 and 7 makes another 10. And then our 4 and our 5 and our 1 make a 10, and 2 more would make the 12 we could add. So there are lots of different ways that we could look at these numbers from her book and see and think about how we could combine them and just do it in our head first, quickly, by looking for friendly number combinations. So if you want to write these numbers down, you could try some other ways and see if you can come up with some different ways to mentally think about how to put those numbers together. And then you could write down the number sentences and double check yourself. And I think we're going to stop with that so that we can have Ms. Sears teach us a game.
All right. Thank you so much. I was kind of thinking about like doing partial sums or something with that. Just once I got close enough to the numbers, as I was thinking about them, I was going to start adding like the 10s together and then the 1s separately together and then maybe bringing them all back together. So sort of like a partial sums. All right. So welcome again today. We're going to just quickly go over our vocabulary that we had on Tuesday. And we were exploring the idea of multiplication. And we did this using a Freire model. You created one of these at home on a spare sheet of paper. And what we had were definitions, the definition of it, the characteristics, examples and non-examples, and ways that we could show that we could multiply. And so kind of here is the completed Freire model that we did, and we just wanted to talk about some of the different ways that we could have done it. Remember that when we're talking about multiplication, that's just the operation of repeated addition. We talked a lot about repeating that same number, that same multiple, and counting that number over and over and over again, seemed like 2, 4, 6, 8 down here. We also talked about some things that multiplication is completely unique in the fact that it has factors. And those two factors multiplied together make a product. When you multiply anything by 0, we've said this, if you add 0 and 0 and 0 and 0 over and over again, you're still going to have 0. So it's always going to be 0. And if you multiply by 1 of any number, you're also going to have that same number. All right. So we're going to kind of be putting this up here in the back. And we're going to get to our game that we wanted to play the other day. And I'm going to ask Miss Obenshane to join me, and you're going to need probably a marker for this. So you might want to grab yourself a marker, a handy-dandy marker. What do you notice about this board? It's a tic-tac-toe board. Well, I also saw like this number sign over here that Miss Gaudette drew about being a smallest number. And some of you who are maybe tech savvy or like to tweet a little bit might recognize this as a hashtag, okay? Like hashtag Corona right now is like a big thing that we're hearing a lot about. So this tic-tac-toe board is going to be the backdrop of a tic-tac-toe game that we're going to play. Well, you probably remember you play with X's and O's, right? This is a little different. We're going to play number tic-tac-toe, where the object of number tic-tac-toe is to use the numbers 1 through 9, or digits 1 through 9, and we have to try and make a tic-tac-toe that is equal to 15, okay? So the tic-tac-toe has to be anywhere going across, or going vertically down, or going diagonally, okay? That's the trick. And we can only use the digits 1 through 9 one time. So we have to think strategically into which numbers we're going to choose and to which numbers we're going to want to put and where to help us try and make that tic-tac-toe as easy as possible. Do you got the directions?
I think so. How many numbers can we put at one time?
We can only put one number at one time.
And we just take turns doing that?
And we will take turns doing that. Thank you so much. All right, so we got to think about this first one.
Okay.
I don't know. I'm always trying to think of like, maybe I should start with the biggest number, because if I feel like I get those big numbers out of the way, then the little numbers are going to be a little easier to place. So I think I'm going to put my biggest number, and I always just like going in the dead center. So I'm going to start with a 9, and that's my biggest number, and I'm going to put that in the middle.
Okay. So
we got to think about combinations to 15 here. So
I'm thinking a 2 and a 3 would help make 15. No, wouldn't make 14, huh?
You just can put one number at a time.
One number, so that I know. So I was trying to think about where I should put them, one to put there. So if I put a 5 down here, then we're pretty close going across.
I'm just going to make sure that this is really dark on there. So I'm going to actually just make it mine over with the black. Okay. So you put a 5 in there. All right. Let me think here. So I want to try and make 15. I could possibly make 15 right now if I think about that number that I want to place there. In order to make 15, I'd have to have a 10, right? So what would I add to that 9 to make that 10? Are you thinking a 1? I'm thinking a 1. I'm going to go ahead and do that. I'm going to make that, and that would mean that I would have a tic-tac-toe, because 9 plus 1 plus 5 would be 15. Perfect. All right. I'm going to let you go first, since now you can maybe be a little strategic in thinking about the numbers. Maybe let's try and make it a little difficult. Let's see if we can do that.
I'm going to try the same approach and but a different big number in the middle.
Okay. So you said 8. What if I put a 7? I could put a 7 right away. Oh, if I put a 7 right away, that 8 and that 7 would already make 15. But I kind of want to like drag this game on a little bit. I'm going to put a 7. I think I'm going to put a 7 right here.
Well, and the thing that I think is smart kind of about you putting a 7 is that I can't use your number to add to my number to make 15. So it keeps me from being able to win right away, just like Miss Sears did. So
I'm always thinking. I'm competitive. You know, normally I'm up here with Miss Gaudette, and we're just very competitive. But
I'm going to try by putting a 1 here.
Oh, interesting.
I still think that she can beat me, but
I think I could, yeah. But so I was thinking maybe if I tried to go this way, I couldn't put the 7 again. Because I know my doubles, and 7 and 7 is 14, right? And that 14 would be 15, but we've already said I can't put a 7 there again, right?
right.
But, oh wait, I mean, you could do 1 and 8. There's that 9 again that I had.
Mm-hmm.
But where could I go? I don't know if I could use that number.
Don't give her any hints.
Let me see. Let me try. I don't want you to maybe get, I don't know. I think I'm going to try a 5. I just feel like maybe a 5 could go there and I could maybe figure something out. Was I close? No. No, 1 and 8 is 9 and 5 more is only 14. I'm not 15 yet. Yikes.
But now that's kind of tricky for me because I can't use another 7 here, so I can't go this way. I can't do this. So now I have to start thinking about, if this, we already have 15 going this way also. Can I use a 0? Is that?
I think we could use 1 through 9.
1 through 9.
Yeah.
Okay. Well, then I think I'm going to go with, I don't know if this is a good idea.
Oh, 2 and an 8 is a 10. I know those complement each other. A 1 and a 2 is 3. We haven't used the 9 yet.
But I still think I might have blocked you from being able to get it.
I think you might have that. Let's see. 9. I'm still thinking, how about, I could come really close, maybe, again. I could get that 14 again. 4. I'm going to try a 4 here. Just because I'm curious. I'm trying to see if maybe that might work. I think I might have given it to you.
I thought maybe you would put a 9 here, trying to get it the biggest number, but
but that would have worked good.
But it would have been that would have been okay because this still might work out for me.
Okay.
So the 4 and the 5 make a 9, and I need to be 15. So 9 and 1 is 10, and then 5 more would make 15. So if I put a 6 here, I think I might have got a tic-tac-toe because 6 and 4 makes a 10, and 5 more is 15.
Why don't you circle that? That'll give us.
And then I can write this down here. 4 plus 6 plus 5 equals 15.
All right. Good job, Miss Obenchain. That's awesome. I thought that we could do another variation of this, but with a little bit harder numbers. Okay.
Ooh.
So this is also tic-tac-toe, except it's tic-tac-toe 3 equations in a row, okay? And in this instance, we have to pick where we want to strategically put whether we're X's or O's. And let's see, I don't know, should we like rock, paper, scissors to see who's X's or O's and who goes first? You ready?
Sure.
Rock, paper, scissors. Paper covers rock. Ha-ha. All right, so this time we're using a little bit harder numbers. All right, and I'm just going to do the first one just to kind of show you really quick because we are actually running out of time. But if I was to go ahead and pick one, I would want to probably pick, again, that center one, and I would want to solve that equation. When I solve that equation, if I do it correctly, I would be able to place my X in there first. Now, what would happen is if we ended up coming up to a tie and we didn't know who was going to be, getting that number of X's or O's correctly, we could use a dice. And I have used this cube template to be able to show us what would happen if I wanted to, if we had an equal amount and we kind of ended up at a crossroads, we were at a tie. We could roll that dice to say, in that case, she would have the O and she would have won that particular game. But this is just another variation of how you could play tic-tac-toe. We did the number tic-tac-toe and then we did the 3 equations in the row. There will be equations on the lesson resources that you will have available to you at APS. Now, we've had a really great day today. We've read a story. We've done some problem solving. We've also done some oral sequence counting, and it's been fantastic. And we thank you so much for joining us today here with At Home at APS. Have a great day. Thanks, mathematicians.